Did it start? It is being recorded. Okay. We are going to move to 4.5 here in a minute after we go through the homework. Analyzing lines of fit. We're going to talk about something called correlation coefficient. Okay. Maya, what do you know about the correlation coefficient? Probably nothing.
Yeah.
Okay, good. That's fine. That's why I get paid money, to teach you that. So I'm going to earn some money today. But before we get to that, let's go figure out your homework or do a little warm up here. Read through this. I know it might be a little bit rough there in the back, but go through here and take a look at that problem, and then we'll get to the homework. Can I give you one? Did you? You know what? It didn't say to.
I did.
But I did.
Okay.
Because, I'm an overachiever. It didn't say to, but I thought it was probably wise to. Yeah, more than
No, it says this is make a scatter plot.
No padding.
No, wait.
Oh, on the bottom.
It doesn't say anything about. If it would be one, I did
You think we got 4 minutes to go through this?
Next time, I have to worry about it. Okay, ABCD, go ahead. All right, you get your homework. All right, I'll do homework if you want to do this.
Yeah.
Give them a minute here.
Yep.
What was it, page section 4.4? Today is Wednesday, right?
Yep.
I'll hand out the answer key in a second.
Right here.
I got him. Nope, that's for tomorrow. Look at me.
Wow.
Look at me.
It's probably all wrong.
Where's it at? Yeah.
You want to hand them out?
Nope. I got it.
They're easy.
Just focus on you.
I'm focused.
What? All right, so you pick 2 points.
Guys,
right?
get this done. Okay, come on.
Equally divide.
Come on.
9.5 divided by 5. Do you think? You done your story. Okay, just write that and then go from there. Okay. All right, homework. See the 9 over there? 2020. It's okay, just divide that and it'll give you a decimal. That's okay in this case. It's okay. Okay. When I lost you. All right, we'll see what we can find here. All right. Yeah. All right, take a look at it. Here, I'll give you this so you can see how I hit 9, because everybody will do it a little differently.
I got you.
All right, who's check?
You guys, give me another minute on this, and we'll talk about the warm-up problem.
All right, make sure you label what does the slope mean and what does the y-intercept mean. So you got to do that for 9. Yep, let me see. Did you label what the slope means and what the y-intercept means? Got to do that. Hey, tell me what the slope means and the y-intercept means for 9. I need more than just an answer or just an equation. You got to read directions. Okay.
I didn't have slope and set meetings.
Okay. Yep. You gotta tell me what the slope means and what the y-intercept means. You can, for this case, you go ahead and get a decimal. Okay. Because it'll make sense in this. Because we already have the line. We already have the line.
Guys, let's look at this problem. Let's talk about it. Guys, what's true about any big city? If you live downtown, what's going to be isn't it going to be more expensive? Okay, like New York City, renting in New York City is crazy. Okay, crazy stuff. Okay, how much would it, if you're in the center, here's distance from the center of the city right here. So the y-axis here is basically the center of the city, right? How much would it cost to rent in the center of the city, Taryn, according to this graph? About what? Yeah, about 1,400. Looks like 1390 or something, 1380, something like that. A little less than, if you're around there. Okay, not quite 1,400, right? Okay, how about far from the city? Okay, well, we know this, right? About 9 miles out from the city, what would that estimated cost to rent? It drops under what, Mace? It drops under 600, right? So if you're around 600, that's what it costs outside the city. Now, estimate the change in rent for each additional mile from the center of the city. Well, we have to get the what? We can do this, guys. Let's use this. How close are we here? 0? How many miles from here? How many miles from 0 to here? How many miles was that? Wasn't that 9 miles? Yes? 9 miles. What was the cost in rent drop? What does that cost in rent? Yeah. Okay, divide that. So it's dropping $760 in 9 miles. What's that per mile? About. What is that? Go ahead.
84.
$84 a mile?
Yeah.
If you're around there, $84 a mile. Now, estimate the change in distance from the center of the city to each dollar change in rent. Okay, let's see. Estimate change in distance from the center of the city for each dollar change in rent.
What's that say?
It was kind of.
I know.
I mean, wouldn't it be basically that? Every mile is what, guys? Every mile, it's about what? $84 cheaper. Okay. All right. Was this the homework?
Yep. Just really well. You guys can read through the answers from 1 through 6.
Yeah, check them real quick.
And then we'll do number 9, or we'll just talk about number 9.
What's that?
There you go. Oh, you didn't get
Here,
Is everybody okay with 1 through 6?
they're taking care of this before class. We go. Aiden, this is the notes from yesterday.
Is everybody okay 1 through 6? All right. Okay, let's look at 9, guys. Table shows total amounts in thousands of dollars of money homeowners save on electric bills in X years after installing solar panels. Okay. You guys see, that was a big trend probably, what, 20 years ago? People were putting them on their roofs.
Shoot, actually, my father-in-law just put them on this year.
Did it work?
Out in Nevada. I don't know.
Oh, out in Nevada where it's a little more sunny.
Yeah, so he did it out in Nevada. And then my sister, she's in Colorado. I don't think she did, but I can talk to her. Oh, I forgot. Because there's a big push out there. So.
Okay. Here's what we need to do. It says write an equation that models the amount of money saved as a function of number of years solar panels were installed. Okay. So let's pick these 2 points right here. Okay. And this. All right. What do we want to do? What's the first thing to do when we want to write an equation? Get the what? Get the slope. Okay, so how can we set this up? You guys see it there worked out, right? So it's going to be what? 10.5 minus a negative 12. And then it's going to be 15 minus 0. So you get 22.5 over what? 15? And that equals 1.5.
Hey, how many people actually picked those 2 points? Okay, so that's okay. You don't have to pick the same 2 points. Our answers will be similar, but not exactly the same. So understand, on a quiz or on a test, by no means do we all have to pick the same points. These were all really close to each other, so really any 2 would work. Sometimes, though, that's why you plot them, because there could be one that's maybe a little bit off from the others. You don't want to use that one. But anything you have should be close to what we get on the paper. Sorry, Mr. Parker.
No, you're good. And then, guys, once we have the slope, you can see on the paper there, what he picked 0, negative 12. Well, guys, that's your 0, negative 12. Isn't this our y-intercept? Isn't this our y-intercept? Okay. So there's your equation. Right there. Okay, you really shouldn't have had, once you get the slope, recognize that point as this. That's my y-intercept. My slope is 1.5. There's my equation right there. Okay, now what's the slope and the y-intercept of the line of fit? What's it mean? Okay, you can see the line of fit there. What's 0, negative 12 mean, guys?
And this is what nobody answered.
That was kind of tough.
Yeah.
That was tough. That would be the cost, because aren't you going to go into negative when you first install something? Does that make sense? Austin, can you sit up, please? Aren't you going to, that is the cost of putting it in, right? So that was the cost of the solar panels, $12,000. Okay, that was kind of a tough question.
Yeah, I agree.
Okay, and then what's the 1.5 mean? How much are you going to save per year? 1,000 what? You're going to save $1,500 in your electric bill per year with the solar panels. Okay, that was a tough question, no doubt about it. Okay, but you should have been able to get. I think you should have been able to write the equation with all this equation work we've been doing.
Yeah.
Okay. All right.
All right, we're going to move into 4 or 5 here. Let me hand out these guided notes.
Yep.
Yeah, should be good. I just need to grab the green.
Yep.
Green sheet.
Thank you. Thank you.
All right. Now, for some reason, I didn't know what correlation coefficient was. I'm not sure why. It was disappointing. but we'll go over it. All right, lines of best fit. That's that line that goes through the data. Okay, and you want to pick something that matches it as best you can. Is you're going to pick some different points. All right, we're going to come up, read through here. It says you can use technology to perform a method called linear regression. We are not going to worry about that. There's a whole big thing you can go through to actually calculate this value. We're only worried about the value itself. Okay, so you can do this to find a precise line of fit. Like you get into statistics, you get into algebra 2, you will figure out what that line exactly should be. Right now, we're not there yet. Okay. The technology will often give a value R, which we call the correlation coefficient. This value tells whether the correlation is positive or negative, okay, whether it's trending up or trending down, okay, and how closely the equation models the data. Okay, values of R range from -1 to 1. It cannot be bigger than 1. Cannot be bigger, less smaller than -1. Cannot. It has to be between those. So it's got to be a decimal. When R is close to 1 or -1, there is a really strong correlation. As R gets closer to 0, the correlation becomes weaker, which means it's scattered. So kind of this should give you a good, little bit better idea. Are these pictures here? So -1, a negative correlation means that the points are going down. Positive correlation means the points are going up. Okay, we already said that R has to be between -1 and 1. So if it is a lot of my dots are really close together to forming a straight linear line going downhill, R will be close to -1. These are more negative, but they're not clustered together. So it's not going to be as close to -1. So that's around -0.6. Totally random. R is going to be close to 0. Okay, more positive, but not really close together, 0.6, and then R is 0.95. That means they're really close to a straight line. Okay, so that's all that R value means is how close it is to, a straight line, either positive or negative. If R is close to 0, it means everything just scattered to the wind, just thrown all over the place. All right. There's a way to figure out what this R is. We don't care about it yet. You're going to care about that later on. I'm just going to tell you what R is. You got to tell me, does it make sense? Now, I don't think this is on your sheet. Don't worry about this. But let's answer this. This is a straight OST question. Select all the correlation coefficients that represent a linear model with weak correlation. What does weak correlation mean? Weak correlation means that the data is scattered. Okay. Strong correlation means it'll be close to a line, either a negative line or a positive line. So what R values, so these are your R values, would be a weak correlation. This isn't making any sense. Griffin.
The -1, or the -0.103, and then the 0.204.
Okay, he's correct. These are close. Whoops, that's a terrible close. These are close to 0. Okay, so we want the 1. So that means that our points are scattered. So this one has more than one answer. These negatives, since they're kind of bigger than like -0.5, that means, okay, there is a pretty good correlation. These points are going downhill, but they're pretty close to a line. A little more scattered, but still look like a line. These are really random here. And these are very strong positive correlations. Okay, so I want to make sure we at least talk about that. What does that R value mean? Is the data scattered or is it close to a line? Okay, is it scattered or is it close to a line? All right, again, this one's not on here. A typical question you'll see. Okay, Brian collects data on the depth of a river at various points and the velocity of the river at those points. In all reality, you don't need to worry about what the velocity is and the depth. You just got to look at the dots, okay, for this one. His data has a correlation coefficient of -0.9382. Which one of these would match that number? Lucas. He says A. Agree. These are going downhill Okay, they're negative and they're pretty tight to a line. Okay, this one here, random. D is random, close to 0. Okay, what would be an appropriate R value for this one? Just you make it up. There's no right or wrong. Appropriate R value, Zach?
0.8.
0.8. R is positive, and it is pretty strong to a straight line or a line. So yeah, 0.8, 0.9. Wouldn't be near 0. All right, good, but your answer to that one would be A. All right. Got to see if I can explain this. This is a tough one for me. It might be easy for you. There's something called correlation and something called causation. Causation means it absolutely makes it happen. Okay? If I eat 5 Big Macs and he eats 10 Big Macs, who eats more calories? He does. It causes it. Okay? Because there's no ifs, ands, or buts. It has to cause that. Correlation means it's likely but doesn't guarantee it. So we want to look at some of these examples and kind of sift through this. All right, when a change in one variable causes a change in another, it is called causation. Okay, the more I eat, the more calories I take. Okay, if I make $20 an hour at a job, the more hours I work, will I make more money? Yes, so the more hours will cause me to make more money. Okay, causation produces a strong correlation between two variables. The converse is not true. In other words, if there's a correlation, it does not imply it causes it. We'll try and explain that. Okay, tell whether a correlation is likely. If so, tell whether there is a causal relationship with it. Absolutely causes it. Okay? I'll say this. The amount you study and the grade you get on a test, that is correlated. But does it guarantee it? If somebody studies 4 hours and somebody studies 1 hour, does it guarantee they get a better grade? No, then it doesn't cause it. That's the difference. Typically it will, but it doesn't guarantee it. If he eats 10 Big Macs and I eat 5, it's guaranteed. He's going guaranteed he'll eat more calories. Okay. Time spent exercising and number of calories burned. Is there a correlation? Does one affect the other? Typically. Yeah. Positive or negative. The more time you exercise, will you burn more calories? So what you want to do, so there is a positive, write this down, correlation. I want to see how I word things here. Okay, is there a causal relationship? Does the time spent exercising cause the number of calories burned to increase? Does it cause it? Yes. Okay, so there's a positive correlation and a causal relationship. Okay, and a causal relationship. Okay, it absolutely causes that. If you exercise 1 hour, you'll burn X number of calories. If you exercise at the same rate for 2 hours, you're going to burn more. There's no ifs, ands, or buts. You cannot get around that. That causes it. Okay. The number of banks in the population of a city. Okay, so if you, over 10 years, let's say the population rises, do you think the number of banks will increase? Yes. That means that there's a positive correlation. Okay, now, is it causal?
Yes.
A positive correlation. Okay, here's your determining factor for causal. If I build 5 more banks, will the population automatically increase? Then it's not causal. Okay? So you can build, it's probably going to happen, but it doesn't guarantee it'll happen. So there is a positive correlation because as your city gets bigger, there are going to get more banks typically, but it doesn't cause it. So there is, let me see here, positive correlation, but no causal relationship. You go, you drive through Canton or you drive through Akron, you will see payday loan stores all over the place. Like say payday loans, payday loans. If you build 3 more, it doesn't mean your population is increasing. Okay, so it doesn't cause it to increase. Okay, but in a bigger city, like if you compare population, there's going to be more in the bigger city. So it doesn't cause it to happen. So if I build another bank, it doesn't guarantee the population is going up. Okay. The amount of organic food you eat and your score on a test. Okay. Is there a correlation? Does the amount of food you eat have any effect on your test? No. So you would just say no correlation, and then you're done with it. If there's no correlation, it cannot be causal. No correlation. Okay, no correlation. Done. Okay. And then what's that 4th one there? Okay, now we're not looking for like the little exception. Basically, let's assume that you get paid for every hour you babysit. Like this is no like you're not freebieing for your aunt. This is like your job. So the time spent babysitting and the amount of money earned. Is there a positive correlation or negative? Yeah, the more time you babysit, the more money you're gonna make, right? So there is a positive correlation. Okay, is it causal? Is it absolutely guaranteed? If you're getting paid per hour, yes. So they're with a causal relationship. It causes it. So write that down. Correlation, yes, it probably affects it. Does it cause it? Okay, no. Okay, so like the number of the coats you buy and the temperature. As the temperature goes down, there's probably going to be more coats bought, but does it absolutely cause it? No. It doesn't force you to go out and buy a coat. Okay, this is a case where it does. Okay, now this isn't on your sheet, but pay attention because this is a really good one. A store manager records the total visitors and sales in dollars for 10 days. The data is shown in the scatter plot. So according to the data, is there a correlation? Yeah, as the number of visitors increase, the total sales increase. Now this is a multiple choice. Okay, what conclusion can the store manager draw? An increase in sales causes a decrease in visitors. Well, does that even make sense? An increase of sales causes a decrease in visitors. Does that make sense? No, so it can't be A. So we discount that. Throw that one out. An increase in visitors causes an increase in sales. Okay, that's a possible. I'm going to put a question mark here. Yeah. An increase in sales is correlated with a decrease in visitors. Absolutely not, right? Because as one goes up, the other goes up. An increase in visitors is correlated with an increase in sales. Okay. It's either B or D. The question is, does it cause it? There is a correlation, right? Does an increase in visitors absolutely cause an increase in sales? Could people go and spend no money? Okay. So does it absolutely cause it? No. So what would we answer for this one? We would answer D. This is D. The first time through, you got to really read through it because you're going to say, "Oh, it's B," and just stop, and then not get to that other part. So you really got to go through that. Does it absolutely cause it? It's probably going to happen, but it doesn't absolutely guarantee it. So it's got to absolutely guarantee it. As the number of visitors increase, how about this? The admission, like the money you get from admissions, increase. Will that be causal? Because everybody's got to pay, right? That would be causal. Okay. Like sales in the gift shop is not. Not everybody goes there. All right. Now this last one. Okay, this is the one where we got your protractor. This is one where we want to come up with the equation. Some people, you might be able to have a really good grasp of this and kind of work your way through it. But to guarantee it, we're going to come up with the equation and see which line most matches it. So look at there, find 2 points, 2 pretty decent points. Draw a line through there that best matches the data. See if you can come up with 2 points that best match, and we're going to have to estimate where they are because we're going to do it this way. Some of you might be able to figure out, oh, the slope and the y-intercept and match it really good, but this is going to work for everybody. So, and if you can find 2 points that you think you know are the values, the x and y values, that's even better. But let's just take a look here. It's got to go through, kind of split. And let's see here. Now, even if you did 2 different points, let's all stick together with our work. See those 2 points I picked? Now, we're still going to have to ask, what is that point on the very end, about what are its coordinates? Okay, Griffin.
2065-ish, 63.
20, all right, you said 63 and 65. Let's split the middle and go 64. So let's use that point, 2064. All right, what's this other point here? We're going to have to estimate that as well, which is okay, because not everything works out nice when you do situations. All right. Alex, what do you think that point would be close to?
8.
Okay.
39.
8 what?
39.
839. Now I'm going to use 38 just because I want to have 2 even numbers just to make this a little bit nicer. But yes, I would use 30. All right. Let's find the equation of that line. Let's find the equation of that line and see which one would match it closer. We are not going to match any one of those exactly. Got it? Now you can also probably discount if you drew that line in. Its y-intercept is about what? According to my information. My y-intercept is about 17 or 18. Which ones do you think we could throw out right off the bat? Mason?
30.
3. Yeah, I think we can throw out that, but we'll just see. I'm not going to throw it out just yet because that doesn't look like anywhere close to those. All right, let's find the slope. M equals 64 minus 38 over 20 minus 8. What is 64 minus 38? So help me out here. Use your calculators. Don't just watch me do the work, Jeff.
26.
26, 48, 58, 26. What is 20 minus 8? 12. All right, in this case, we already have the line, right? We drew the line. We don't have to graph it. When we graph it, that's where we really keep it as a fraction so I know how far up to go over. Now I want to know the slope. What's 26 divided by 12? We'll round it off. Diana, what do we get?
2.16.
2. Is it repeat? All right, 2.16. What can that round to? I'm going to round it to 2.2. Does that make sense? So use that as your slope, and I'm going to use y minus y1 equals m times x minus x1. And it doesn't matter which point. I'm going to use the point 838. And I'm going to substitute in. Now, we should be good. This is your test, and I'll tell you what, most of you did really good on the test. Last quiz we had, we'll substitute in. So it's going to be y minus 38 equals 2.2 times x minus 8. And I get 2.2, x. What is that? 2.2 times 8. Is that 17.6? I'm not done. What do I got to do, Addison?
You add the 38 to 17.
All right, let me know what you get when you add 38 to it.
20.4.
So 20.4. All right, so that's my equation. Which one then makes the most sense? B. That's 2x plus 20. We had 2.2, and we had, what was our 20.4? It's pretty daggone close. So I can confidently say that is B. Now, some of you, like a few of you, not many, might be able to figure out, like draw that in and kind of have a good idea where it is, this will guarantee you get it right. Okay, this will guarantee it. All right. So for that one. All right, 15 through 20. That's actually 6 problems. We're talking about use your notes because you have to say causal versus correlated.
Correlation, yeah.
Yeah. Reason. Oh, 15, 16, 17, 18, 19, 20. I always thought that too.
Yeah, you kind of forget to start that.
Yeah, I always thought that too. You don't have to graph on this one, this assignment, so you don't need graph paper. All right. Oh, let me. Oh, shoot. All right, where'd it go?